Rust closures and iterators. Closures and iterators make Rust code clean and expressive. Closures are anonymous functions you can store in variables and pass to other functions. Iterators let you process collections step by step. Together, they replace most loops with short, readable code. Let us learn both in this video. A closure uses pipes instead of parentheses for parameters. If the body is one expression, you do not need curly braces. The biggest difference from functions is that closures can capture variables from the surrounding scope. A regular function cannot do this. It only has access to its parameters. You can write functions that accept closures as parameters using impl.fn. This means any closure or function that matches the signature. You can pass different closures to the same function. This is how you create flexible, reusable code. The closure is inlined by the compiler for zero-cost abstraction. Rust has 3 closure traits based on how they use captured variables. fn borrows immutably and can be called many times. fn mut borrows mutably and can modify captured state. fn once takes ownership and can only be called once. Every fn is also fn mut, and every fn mut is also fn once. The fn trait is for closures that only read captured variables. They can be called as many times as you want. The captured variables remain valid after the closure runs. This is the most common closure trait you will use in Rust. Most iterator methods like map and filter take fn closures. fn mut closures modify their captured variables. The function parameter needs the mut keyword. A common example is pushing elements to a vector inside a closure. fn once closures take ownership of captured values and can only be called once. Use fn once when the closure needs to move data out of itself. The move keyword forces a closure to take ownership of all captured variables. This is essential when passing closures to threads because threads might outlive the variables. Without move, the compiler rejects the code. The original variable is no longer available after the move. Functions can return closures using impl.fn. The returned closure must use move because it captures local variables. Without move, those variables would be dropped when the function returns. This pattern lets you create function factories like makeAdder and makeMultiplier that produce customized functions. Iterators produce a sequence of values one at a time. In Rust, they are lazy, meaning they compute nothing until consumed. Every collection has 3 iterator methods. Iter borrows elements. Iter mut gives mutable borrows, and into iter takes ownership. Choose based on whether you need the collection afterward. Map transforms each element. Filter keeps only matching elements. Fold reduces everything to a single value with an accumulator. Sum is a shortcut for adding all elements. Collect gathers results into a new collection. You usually need a type annotation with collect so Rust knows what to create. The real power of iterators comes from chaining methods. Take numbers, filter the even ones, square them, then sum. This reads like a pipeline. Compare it to the equivalent loop with a mutable variable and if statement. The iterator version is shorter and harder to get wrong. Both compile to the same machine code. Here are useful practical functions built with iterators. Sum of squares uses map and sum. Even numbers uses filter, copied, and collect. Word lengths maps strings to their lengths. Flatten and sort combines nested vectors into one sorted list. Each function is just 1 or 2 lines of code. You can implement the iterator trait for your own types. You only need to implement the next method, which returns an option. Return sum with the next value, or none when done. All other iterator methods like map, filter, and sum come for free. This makes your custom types work with the full iterator ecosystem. Here is a Fibonacci iterator example. The struct holds the current state. The next method calculates the next number and returns sum. When the count reaches the maximum, it returns none. You can then use collect, sum, map, and every other iterator method on Fibonacci numbers. Rust iterators compile down to the same machine code as handwritten loops. The compiler inlines the closures and optimizes everything away. This is called zero-cost abstraction. In benchmarks, iterator chains are often faster than loops because the compiler can optimize the whole pipeline at once. Here is a reference of common iterator methods. Adapters like map, filter, enumerate, zip, take, and skip transform iterators lazily. Consumers like fold, sum, count, collect, any, all, and find produce final values. Chain concatenates iterators. Flatten removes one level of nesting. Here is a summary. Closures use pipe syntax and can capture variables. The three traits are fn, fnmut, and fnonce. Move forces ownership transfer. Iter borrows into iter consumes. Iter mut gives mutable access. Custom iterators only need the next method to unlock the full iterator API. In the next video, we will learn smart pointers. Box puts data on the heap. RC enables shared ownership in single-threaded code. Arc works across threads. RefCell provides interior mutability. These types give you more control over how data is stored and shared in complex data structures. If you like this video, hit the like button and subscribe for more tutorials.